Yes, this tiny thing here is a computer inside of Minecraft. Certainly not a very capable one, but let me explain. Hello and welcome back to this channel. This is so-called Automaton inside of Minecraft, a very limited form of a computer. So what even is a computer? Well, of course, you're probably watching this video on a computer, but for the purpose of this video, we define a computer like a program. It gets some input and returns some output. So for example, you press a key on the keyboard and then you can input something into a field. Or you move your mouse and this pointer moves on the screen. You can see everything you do has an input and then an output, what you can see with your eyes or hear with your ears. Well, for this video we want to limit us to a very specific computer which gets a string, so an arbitrary amount of characters, either accepts the string or declines it. So this is basically asking questions about the string. So for example, if you log in with your password and it says, well, your password is not long enough, not secure enough, then this is exactly this question with what our computer should do. And this is also the basic concept that scientists over 100 years ago started with, and today we got the computer out of it. So why don't we recreate this basic concept of a computer inside of a game? But first we look at the concept. So here is such an automaton that I spoke about, and you can see it's very different to the usual programming language or how you would picture a computer. So here we got the so-called states, and you can imagine this is kind of like the memory. So this machine here can be only in one state at the same time. And we start with this state here, which is marked as start obviously, and for now we are in this state. And then you can see I also drew some connections here and also some letters. I restricted myself even more on just the binary alphabet, so 0 and 1, but of course you can do a lot with that already. So let's think of some string that is in binary. So for example 0101. If we follow one of these so-called transitions, you can imagine we are reading one character from our string. So our machine can only see the current character and follows these transitions like shown. And we can see we are in the start state here and follow the 0 to the other state. So after reading this 0, we are now in the other state and can read the next character, which is a 1. So we go back to the first state and read the next character, which is again a 0. So we go back into the second state and then again read a 1. So now we are at the end, and do we know something or not? Well, you can see the first state that I've drawn also has a second ring around it, which simply means this is an accepting state. So at the end of the string, when we are in this state, we are accepting the string. So let's do this again with another string, just 0, 0. And we can see we go into the second state. And then there is no transition for this state. So we are in no state. And of course we refresh the string, but we are not in an accepting state. So we decline this string. I hope you can see the structure for now. And it might also be obvious that this automaton here accepts strings that are 0101 arbitrarily often. So with this knowledge, I hope it wasn't too boring. We are getting back into Minecraft. And you can see this is a similar setup. And we have this string here. This can be arbitrarily long. We can build it with blocks. And this here is a field where it displays the current character, which is in this case the 0. And then you also see this machinery here from the beginning. Of course, this entire thing here is made with Datapacks, so this is not vanilla redstone. And as in the drawing, we have these two states here, which are marked with the redstone lamp. And right now we are at the first character, red, the 0 here. And thus we are in the second state and it lights up. So for the various actions I created this book here. And we can also do a step. So reading the next character, which of course would be a 1. And you can see it switched to the other state as well. What's going on with this redstone block here, explain in a minute. But of course we can do another step here. You can see there is a redstone signal here. The last step, which results into the first state, again being active. And then if we read nothing, we can see it accepted our word. So you have seen we have these states here, and then the transition with the node block. And then on top you can specify your character, and then another state. You can also see this little campfire here, which points into the direction where the redstone signal comes from. As you've seen, if the transition happened, the datapack will place a redstone block here, so it knows that the next state is triggered, which is reachable by this redstone dust here. And of course, with this concept here, you can do all kinds of stuff. Let me show you another example, and I will also explain how this works in more detail. So here we go, I cleared the area, and let's summon a new state here. You can see in the direction where you're looking, the redstone block will be placed. So then let's make a loop here. Summon a transition right here, which should take black concrete. And then go back into the state itself, which is also possible. So basically now we created an automaton which only reads zeros. And of course we have to make this the start state right here. And of course we can try it. Let's say this input here, so it should fail because there is 1 here. So let's click start. Yes, it is in that state. Step 1 further, another 1 further, and the last one is a 1, so it has no transition here. To the last thing, it says declined. Of course we can't accept it. And we don't even have an accepting state right now. So right here, let's summon another transition that will then take white concrete. So a 1, and then of course go into another state. So what I'm trying to create here is a machine that accepts only the strings that end with a 1 here. So this string here would be accepted. Of course, if there was a black concrete here, it would not be accepted. And let's see. So we can, with this loop here, we can read the black concrete. And then if we read a white concrete, let's go into accepting state. So you can make it final right here. So let's see if this works. We can step through. It stays in the first state because we've only read black. And then it reads the white one, goes into this state here. And of course this is an accepting state. So if we finish reading, it says accepted. Of course this will only accept it if there is black concrete here before, so if we place white concrete here, we can see it is directly in the second state here, and if we step over, you can see it's in no state and it will decline. So what can we do that it is also possible to read any binary combination and then at the end a 1? Well, we can go from the second state here again outwards. If we read a 0 like here, we can basically go back into the first state and there read more zeros and then in the end read 1 1. So let's extend this here, of course with a transition. That should read black. And now we can ask ourselves another question. What should we do when we are in this state here and read a 1? Basically this is valid. And if this is the last one here, we simply stay in this state and accept. So we basically have to create another loop here, like before. So let's summon a transition here. That this goes back into the own state and should take a 1. So let's try this by making a binary combination here with 2 1s, 0 1. And let's see if this accepts. So now we've read the first one. It is in the second state. Step 1 over. It is still in the second state because we have 2 1s. Then step 1 further. Now we are in the first state again, which reads a 0. And then another step. We go with the 1 here again into the second state and accept the string. And if you've paid attention to your math courses, you may know that a binary string which ends on a 1 is exactly the odd numbers. So this little machinery here inside of Minecraft can detect from a series of blocks whether it is even or odd. Now still for this kind of contraption here, it is quite complicated, and there is actually a way to make it easier. As we've seen it right here, it is so-called deterministic, which means in each state we know exactly what to do. We read one character and we know we either go this way or we go the other way. And thus we can also be only in one state at once. And now this supports also a non-deterministic automata. So if we remove this state right here and add another loop right here, which will have a transition also with white back into itself, we can see there are now 2 transitions with the white block, and thus we can be in this state and the other state at once. So we basically have a loop at the beginning which can read any binary string that we have, and then also another transition here which checks if the last character read is also a 1, which also means we don't need this transition anymore and we can just have the final state. So now we have it like you would intuitively think and describe these strings. It is any number of 0 and 1s before and then 1 1 at the end, which makes a lot more sense than the complicated machinery that we had before. So now let's try this. We are in the start state and have read a 0 right here, so we remain in the start state. Now we read a 1 and you can see we are in the start state and also in the other state, which makes sense because if this here would end there, we would have to accept. By the way, it accepts if there is at least one accepting state. So let's step through, and you can see there is no black transition outgoing here, but there is one here, so we are just in the first state again. And let's step again. Of course we are in both states again. And the last step accepts the string. So you can see this is quite an abstract concept, but it was one of the concepts that led to the invention of the computer, and is also today highly relevant. Make sure the password is at least 6 characters long, has combined letters, or the email is in a valid format. And also programming languages rely on this here to validate if a program written by you is valid or not, or give you hints if it's not. In the description you can find a download for this pack, and of course you can also look at the code there, which is about 200 lines of Object-D code. So it might also be a quite good example for what Object-D can do in a very short format. I have to admit, it is not the cleanest code that I've written so far, but you can take a look. Under the hood it is not terribly complicated. If there is anyone that is interested in how this works in detail, let me know, maybe I'll do a follow-up video. See you soon and have a great day, or should I say year. Bye.